Are there any homework questions before we get started on the notes for today? Any questions over the homework assignment? Okay. Let's look at number 9. Nine is g of x equals x plus 4. Now the general form for this linear equation is a times x minus h plus k is what we have. Now there is no value for a other than 1, so that's not going to cause a vertical stretch or shrink. That value is not negative, so there is no reflection. The only thing we really have is this plus 4, which is the place of k. Now k is moving it either up or down, and it will be moving 4 units, but which direction is it going to go? It's going to go up, so it would be up 4. It's just up 4. So I put the f of x equals a parentheses x minus h plus k each time just so we can see it. So if that helps in visualizing what's going with what is h, what is k, what is a, where they connect, write it. If that's helpful, write it. If it's not and it's not helpful and you can see it without it, you don't have to write it. So again, the main reason I write it is because for some it is helpful to see that connection. For others, it's not. If it's not helpful for you, you don't have to. But if it is, write it. Does that make sense? So there's a lot of stuff I will write and do on the board that seems and this helps some. If it's not helpful for you, you don't have to use it. All right? Yeah, so it's going to be up 4, down 4, vertical stretch, vertical shrink, reflections, yes.
So it's the same for
Yeah, essentially it is the same because the difference is, because for quadratic, f of x equals a, x minus h squared plus k. Yes, and then absolute value. No, because that one, if we were to look at it, it would be a constant function. So it's that flat line, and it's up 2. Yep. So I won't count off on stuff like that if you get it wrong. I will put notes sometimes, because, yeah, and just, and so if you do put more than that, I will still put comments. Yes. So I will still kind of still grade it like normal, but it won't count against you. If you do notice that and I did count it off, tell me and I'll fix it. But because there's every few times I'll get in that mode of just grading them, and I'll still hit that one because I about took points off on someone else's because they had them. But again, does that make sense? Yes. Yes. There's no other questions. We're going to go on and look at the notes for today. Okay? What we're looking at today is this here. Now, I think I gave you all of the writing already for this. Yes? All that's filled in? Okay. There is a lot of writing there. So, with most of these here, we'll look at the formula. I'll explain it, read through it, and then we're going to see what's important from it. Because a lot of this is the general terminology, how we talk about it, how we reference it. Not all of it's actually useful for us when we're actually trying to apply it. Horizontal, vertical translations. We have talked about this. This is a part of our last section, 1.2. Horizontal translation, the graph of y equals f of x minus h is a horizontal translation of the graph left to right. And the reason that we have a little bit different notation is these, we're not looking at an equation and saying how much it's moving left or right. We are actually moving the graph left or right by that amount. Does that make sense? So the key equation for this here is this here, this f of x minus h. Because substituting the, or Subtracting h from the inputs before evaluating the function is what's going to move it left or right. So whatever our movement left or right is, we're going to put it in place of h to apply it to the function. So the key part is this equation here, f of x minus h, is our horizontal translation. So I would circle it, highlight it, make some point of emphasis for that there. So when we're applying a horizontal translation, we're going to be using this f of x minus h notation to apply this transformation left or right. The graph of y equals f of x plus k is a vertical translation. Key part right there. Of the graph y equals f of x, where k is not 0, because that just means it's not moving up or down. And that k value is the amount that we're going to move it up or down. And we're just going to plug that value in for k to get there. So our f parentheses x minus h close parentheses is what we're going to use to move the graph or the function left or right. Our f of x plus k is what we're going to use to move the function up or down. And that kind of matches up with what we had the last 2 days. H tells us our left to right. K tells us up, down. And in the last ones that we've done, we were just describing how far the function moved up, or how far it moved down, how far it moved left, right, the vertical stretch, vertical shrink, reflection across the x. We were just looking at the equation and describing what happened to it from the parent. These here, we're going to take a function, 2x plus 1, and apply these transformations to it. So we're going to change the function itself. So this first one wants us to do is write a function g, whose graph is a translation 3 units down of the graph of f. So it's saying we're taking this function here, 2x plus 1, and moving every point on it 3 units down. So that's the key with this here. We're moving everything down 3, and we'll get a new equation that represents that. Now the terminology here, write a function g. All we're doing is naming it. We're naming the new function g of x. That's all there is to that there. So we're wanting to write g of x as a function translated 3 units down of f of x. Now the general form for our up and down is f of x plus k. Because that's our vertical translation, up, down, f of x plus k. So the general form, g of x, our new function, is going to be taking f of x plus our movement, up or down. Now, it won't necessarily always be plus that amount, because plus, if we're adding something to it, we're moving it up. If we're moving down, we will add a negative, but adding a negative is the same thing as subtracting. So we're either going to add or subtract. So for this one here, we'll say plus, what is our value of k? It's from our 3 units down, yes? So it would be minus 3 or negative 3. Because we're taking f of x and moving it 3 units down. Down is our minus, and the amount we're going is 3, so we're minusing 3. We're taking all the function, all the values of the function, and moving it down 3. So our value of k, and if you want to write that, if that is helpful, saying that k is equal to negative 3, k is negative 3. it's moving the function down 3. So for the general form, we have our f of x plus k, so our f of x plus our negative 3. We good with this so far? Now the only thing we have left is to actually get the functions. We've replaced the k, but what is our f of x? What is the equation for f of x? Well, it gave us to us up here, yes? Because f of x is what? 2x plus 1. So to get what g of x is, the next thing we need to do is replace f of x with its function, which would be 2x plus 1 plus negative 3. Now at this point, could we have dropped the parentheses around the negative 3? Well, yes, we could have. I just decided to leave them there for now. Questions on how we got to this here? So g of x is just our new function, just a new way to name it. Yeah, so they told us to write a function g of x, so we used g. If they wanted z of x, we would have just said z of x, or q of x. It's just a way to name the new function. And part of the reason that we do that and why we use g, well, there's really no reason. They picked g. It was just what letter they picked. Because we could have said h of x. So instead of starting out with g of x equals f of x plus k, we would have said f of h of x equals f of x plus k. And the letter choice is just one we picked. Now, the reason that we use g of x, f of x, all of these is so I can name it and know the difference. Because once we get finished with this, if I said we're talking about g of x now, well, I know we're talking about this one down here with 2x plus 1 plus negative 3, and not just 2x plus 1. So we can talk about different equations at the same time and still be able to know the difference. Because when it boils down to this, g of x, f of x, h of x, all of those are just taking the place of y. Or if we all had them written as different y on all of them, there's no way to tell the difference. Does that make sense? So it's just a way to name the function. And on some of these here, we will have some that have more than one step. And all the in-between steps, you can name it what you want. Now, for the most part, I'm not going to be a nitpick on what you name it. If you keep it with g of x, h of x, q of x, as long as you have something there for it, I'm fine with that. Does that make sense? I think hopefully I answered that question. All right. Now, there's one last thing we need to do to finish this problem up is we just need to simplify. Okay? So what we'll do to simplify is we're going to drop the parentheses around both of these here. Now, since there's not a number or sign in front of each one of the parentheses, there's nothing we have to distribute through. So the 2x plus 1 just stays 2x plus 1. Our plus negative 3, we can just say that is minus 3. Are there any like terms that we need to combine? One minus 3, yes? And what is 1 minus 3? Negative 2. So our new function, g of x is equal to 2x minus 2. So this is the function from f of x with every point moved 3 units down. So 2x plus 1, this is our original graph. Our new graph is 2x minus 2. If we look at all of the points from blue to red, they're all going to be 3 less in every single spot. So the one in blue, so we had 3 to 0, 5 to 2, 7 to 4, 9 to 6. It is all this decrease of 3. So it did indeed decrease the entire function by 3. And that's it. Questions on this here? We feel comfortable with this so far? Yes? Now, no matter how quote unquote crazy or elaborate we get with this, if you stick with these formulas, this f of x minus h, f of x plus k, just doing those one at a time, these aren't that bad. But when we start trying to do more than one transformation at the same time is when it starts getting hairy, because you're trying to keep track of a lot of things at once. So no matter how many transformations we do, the best thing I would advise is just do them one at a time. Stick with the formula and let's do it one step at a time. So if we look at this next one here, write a function h whose graph is a translation 2 units to the left of the graph of x. So again, this one, we're not going to use g of x, we're going to use h of x. Again, it's less of a set rule and more of a preference of what we want to name it. Our function, our final function is going to be h of x, whose graph is a translation 2 units to the left of f. So we're still using our 2x plus 1. Now, part of the reason we know we're using it is because it said f of x, not g of x. Now, we could have applied it to g of x, but here we're sticking with f of x, our 2x plus 1. Now, since we're talking about a horizontal translation moving left or right, f of x minus h is the general form that we're using. Now, for this here, what is the value of h? H is going to be 2, yes? Would it be positive or negative? Negative, because it's moving to the left, yes? Now, as I harped on yesterday again and again, left and right's the opposite of what we think, yes? When we're describing it. When we're describing it, we're saying what the movement is, interpreting it in the graph. When we're applying it to the graph, left is still negative, right is still positive. We get that distinction? Up is still positive, down still negative. When we're applying it, we're going to treat it that way. So our value of h is indeed negative 2. Okay? So let's plug that in for its value. So inside the parentheses, we now have x minus negative 2, yes? Do we ever leave it as a minus a negative? No, we normally rewrite it as plus, yes? Well, that lined back up with what we did yesterday and the day before, didn't it? Because it's moving left, so the value of h is negative. But once we put it into the formula, it now looks positive. Yes. Yes. So it wants us to translate it. So we want to write it. So where we got the 2 from was right here in the problem. So it asked us to move it 2 units to the left. So we get the 2 from that. Now, since left is considered a negative direction, it would be negative 2. Yeah, the 2 is more from the problem. It asks us to move it that far. But yes, good question. Because if you ever wonder where a number comes from and you're not quite sure, ask. And I will definitely explain it. And there is a very rare chance I might have just grabbed it the wrong number. So always good to ask if you're not quite sure where a number comes from. Okay. We ready for the next step? Now, you don't have to rewrite this. I'm going to rewrite this. Our f of x equals 2x plus 1 because, well, for me, on the board, the function f of x is higher up on the screen. We can't quite see it. Y'all can still see it on your page. That's the only reason I'm rewriting it. Now, do we have f of x anymore? Because our h of x is equal to what? F of x plus 2, yes? We don't have f of x anymore. We have f of x plus 2. Yes? Well, what did we do? We replaced every x. We replaced the x here with what? X plus 2. So what do you think we'll do to the other side of the function? Because we replaced this x here with x plus 2, yes? X plus 2 in place of that x. Because we replaced the x with what? X plus 2, yes? So we replace every x in the function with x plus 2. We replace the whole statement. Now this isn't any different if we said f of 3, if you remember in Algebra 2, or Algebra 2, that's right now. Algebra 1, where you took f of 3, and you plugged it in every spot in the function, you replaced it with 3. You replace the whole statement. Yes. So for us here, this function, the 2, would still be there. But we don't have x anymore. What we have now is because f of x is our function, so our function is still referring back to this here, f of x plus 2. It's still referring to the same function, but we're not talking about it in terms of x. We're talking about it in terms of x plus 2. Now, this is a side note, because normally when we talk about a function with this here, one of the ways that we can think about this is inside that parenthesis just a box that we can put stuff into it, that we can input this information in. And what it does is it gives information out in a certain way. Now for us it was 2, and our normal function f of x equals 2x plus 1, yes? Well, f of this box equals, it wants you to take whatever is in that box, multiply it by 2, and then add 1 to it. So our normal function was f of x equals 2x plus 1. So here, for this here, we put x into this box, so x goes here. So if we put 3 into here, for f of 3, everywhere there's a box or an x, over here we would also put a 3. Uh-huh. Okay. I do need to finish this out because it is plus 1. So here, this 2. So this 2 came from the function itself. So the function itself is 2x plus 1. We still have the 2. We have every other part of the function. We are replacing every x in that function with what's here. Yes. We added x plus 2 instead of x because we're replacing every x with it. Yes. Because it's, yeah, we got rid of the f because the f of, well, let me rewrite this so it might seem a little bit better. Erase all these arrows so that I can have room. Because really what we're saying with this here, I'll erase it, is that this f of x plus 2 is equal to 2 times x plus 2 plus 1. So really, h of x is equal to f of x plus 2, that transformation. Well, f of x plus 2 is equal to 2 times x plus 2 plus 1. So it's this long, they are all equal to each other. Does that make sense? So the f of x plus 2 is technically still there, but we know that, let me get a highlighter. These two are indeed equal. They are the same function. Yes? Because that's going to be our new f of x, or f of x plus 2. So instead of rewriting f of x plus 2 each time, since we know that they're the same value, same notation, I don't have to necessarily write calligraphy this again. Since these are the same, I can just say that it is h of x. Does that make sense? Or kind of make a little more clarity? Because that's all we're doing. And instead of, and again, mathematicians have a tendency to be lazy. So instead of rewriting f of x plus 2 and continuing on with the h of x, we're just going to say it's h of x. Does that, I think, explains it. Because that f of x plus 2 for us at this point is helping us define the new function so that we can see what it is and how we apply each part of the transformation to it. Hopefully I'm answering the question, not confusing anymore. Okay. Awesome. And again, if I do start, as soon as you get it, if it makes sense, you can stop me, okay? Because I do know extra information sometimes will confuse you more, especially once you get it. But yeah, the key to it is that we're using it to help us apply this transformation here. So it is our 2 times x plus 2 plus 1. Now, if there was anything else applied to it, because our quadratics, we won't really see them here because that's going to be next chapter. Let's just say it had an x squared. When we plug it in, our new one would also have the squared, because all we're replacing is just that x. Anything in front of it, anything behind it, anything applied to it stays. We're just replacing the x. Okay. Questions? All right. Now, we need to simplify. So, the main thing we need to simplify first is our 2. We need to distribute it through. Now, yes, bless you. As we multiply, distribute that 2. So our 2 times x is 2x. Our 2 times positive 2 is going to be positive 4. And we still have our plus 1. Yeah, so we need to add our like terms. So h of x is equal to 2x plus 5. And that is finished. I'm going to switch the 2 of y'all. Yeah, so you're not having to do that all day. But questions on these 2? Let f of x equal 4x minus 9. We want to write a function g whose graph is a translation 5 units up of the graph of f. Now, out of the 2 of these, I think this is a little bit nicer than left-right. Would you all agree with that? Because for the most part, we're just taking that number and adding it to it. Now, for us here, so our new function, we're going to call g of x is equal to f of x plus k. Because our f of x plus k is our general form of moving the function up or down. F of x is our function. K is the value of the movement. F of x is talking about the function itself. K is talking about the movement. Now, our value of k is going to be 5, positive 5, because we're moving up. Since it's moving up, it's going to be plus 5, positive 5. We can put the parentheses around it if we want because we're inputting a value, but with +5, it's not going to make a big difference. And since we're adding it, it's not going to make a big difference. It's not going to change anything, the signs wise.
So then x
Yes.
g of x equals 4x minus 9 plus 5.
So yes, our next step would be to replace f of x with its function. So we replace it with 4x minus 9. Now, could I have done that in the previous step? Replace k and f of x at the same time? Yeah, we could have. Yes, I'm trying to go at a slower pace so that y'all get this. These transformations are one of the more challenging parts of this chapter, one of them. But again, it's as long as you're understanding step by step and getting this, these aren't that bad. It's when we're trying to do a lot of it, and sometimes there's just that one piece that's just missing. Makes them a little bit more difficult. Yes. So we can drop the parentheses around the 4x minus 9 because there's not a number in front of it, not a minus sign in front of it that's going to change anything. So it just stays 4x minus 5.
G of x equals 4x negative 4.
And we combine our like terms. -9 plus 5 would be -4. Giving us 4x minus 4. Now, one thing that is interesting with up-down, especially with these linear equations, is here we move the equation up 5. So it took it from -9 to -4, yes? What would happen if I took the original equation, 4x minus 9, and moved it up 9? Well, the -9 plus 9 would become 0. So it would just be 4x. So it is possible for that number to become 0 and go away. Questions on this here? Let's look at the next one. We want to write a function h whose graph is a translation 1 unit to the right of f of x. Again, I'm going to rewrite the function mainly because, well, I had to scroll down and the function's still higher up on the screen so we can still see it. So we have this here. Now, here we're naming the function h of x. And we're moving it to the right. So we're moving left, right. So our general form of this translation, this horizontal translation, is f of x minus h. Right, so we need to find our h value. And if it helps to write the h value, because our h value, the value of this movement, 1 unit to the right, which would be +1. Because right is going to be positive, and the amount we're moving is 1, so h is +1 or just 1. Now at this point here, we're going to replace h with its value. We could put parentheses around the 1. It's not, doesn't make a difference. But it ends up giving us f of x minus 1. Again, that kind of opposite direction with left, right. Because it is indeed going right, h is indeed positive. But once we put it into this form, it now looks negative, yes? Yeah. Questions on this here? So like the one we did previously, we now need to get our function. Well, now we have f of x minus 1. We replace the x in f of x with x minus 1, which means we need to replace every x in its f of x equation with x minus 1. We have 4 times x minus 1 minus 9. Yes. Any questions on this here? So the 4 is from the function itself. Because we're taking every part of that function, that equation, and it's going to come down with it. The only thing that we're replacing is x. So, let's see here. Yeah, I'm going to have to go way back. That's fine. Whenever we look at a function, the x, you can consider it a box. We were talking about this a little bit earlier. It's just a placeholder, more or less, of what we're putting in. We're used to f of x, and here we have 4x minus 9. Because if we took f of 2 for function notation, we just plug 2 into the function, yes? So here it would be 4 times 2 minus 9. 4 times 2 is 8, minus 9 is negative 1. We're comfortable with that, yes? If I said it was not 2, let's say negative 7. Well, we would do 4 times negative 7, which is going to be negative 28, minus 9 is negative 37. We're comfortable with these two here, yes? Because y'all remember doing these in Algebra 1 vaguely? A little bit. It's just another way to input these in. But what we put in here doesn't have to be just a number. We could do anything for these functions. And it still works the same, because we could say star. Well, we have 4 times star minus 9. We're just replacing that in the function. Everything else stays. So when we look at this last one, or what's inside here now become x minus 1. Well, every x in the function is now going to be written as x minus 1. Because we're very used to having it just be a vet x, a number, a single term. It's a little more of a stretch if we haven't seen it before by putting 2 terms, our x minus 1, this expression, into it. Does this make sense? And this, again, it's sometimes, once we see it for the first time, it's kind of hard to wrap our heads what we're doing. But it's just taking that term and plugging it in for x. It just happens to be x minus 1. I think that answered the question, kind of. But the last thing we need to do is distribute.
4x minus 4.
Because our 4 times x would be 4x. 4 times negative 1 would be negative 4. And that's it. Kind of feel a little more comfortable with that. Yeah. And we will cover more of these, especially towards the end of the year. There is something called a composite function, which we end up putting one function into another, the whole equation. So, and most of this here is, I would say, less really hard in and of itself. It's just keeping those steps in order. Because if we take it one step at a time, we can do each step. It just, sometimes it seems a little overwhelming. Questions on this here? Okay, let's look at this one here. I don't find the problem funny. I just find that it's how vastly different left and right and up and down is, especially when they look at these here. Because if we look at this here, we want to write a new function that is a translation 5 units up, yes? What's the name of our new function? Didn't have one. All right, pick one for me. G, yeah. Our new function is going to be g of x. We just have to give it a name. Now, our generic version of up and down is going to be f of x plus k. Well, for us here, what is the value of k? We all comfortable with how we got positive 5? Yeah. So now, We're going to replace k with, we could put parentheses around it. And we could do this all at once. We can replace the f of x with its function 3x. Now here, it stayed 3x. We didn't change anything about it. The reason for it is, well, did f of x change? Because f of x, what's inside it's still x, yes? So it's still 3x. Now, this might be confusing because what we did with this here is I replaced every x here with x. So in the equation, I replaced the x with an x. Well, did anything actually change? No, it's still 3x, yes? And we get this here, all right? Well, since there's not a number in front of the parentheses besides 1, we can drop them. And that's it. That's kind of what I was semi-chuckling because it's like, really, we just stuck a 5 onto the end and got our new transformation. We'll pick this up tomorrow. Okay? Because, again, we could have probably got through this a little bit quicker, but I want to make sure y'all are understanding it.